This video is for lesson 4.5, in which you are going to learn about proving triangles congruent using the side angle side and the hypotenuse leg congruence. Please make sure you do write in the learning target, and then also you should be using pencil to take these notes. So our first vocabulary is this one here. In a right triangle, the adjacent sides, the sides that are adjacent to the right angle, are called legs, and the opposite side from the right angle is called the hypotenuse. So if I was to draw a picture of a right triangle, which we did in class just the other day, the sides here that are adjacent to the right angle, right here, are called legs, okay? And then the side that is opposite from the right angle over here is called the hypotenuse. So, and it is always the longest side of a right triangle as well. Okay, and then let's take a look at the postulate 20, side angle side congruence postulate. We're going to learn a total of 5 congruence postulates. So we've already learned side, side, side. Remember, that was where if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. Well, we're going to learn side angle side today, as well as the hypotenuse leg, and we can abbreviate that with HL. But we're also going to learn 2 more in another video, so just so you know what's coming up. If 2 sides and the included angle, and I'm going to explain what included means in just a moment, of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So the word included means between. So between the 2 sides that are congruent, we should have an angle that is also congruent, and we're going to look at an example of that. Theorem 4.5, the hypotenuse leg congruence theorem, says if the hypotenuse and a leg of a right triangle are congruent, so let's go ahead and fill this in. If the hypotenuse and a leg, which we just defined over in our diagram to the right, of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the 2 triangles are congruent. So we will be taking a look at hypotenuse leg in this video, as well as side angle side. And in our first example, they want us to use the side angle side congruence postulate to prove that these 2 triangles are congruent. So what we need to find, remember, is we have to have 2 sides and we have to have an angle between the 2 sides. Okay, so that's what's required with side angle side. And notice that they have the A in between the 2 S's in the abbreviation. So that's what can help remind you that the angle has to be in between. So let's go ahead and list the things that we see. The 2 sides that I see here, 1 tick mark on BA, and we also have 1 tick mark on DE. And then we have 2 tick marks on BC and another 2 tick marks on FE. So those are the things, the sides that are congruent. And if we look and see if they are between, so basically what you have to do is say, well, if I trace this side down to this vertex and I trace this side down to this vertex, if that is the angle where the 2 sides come together, if that's the angle that is marked congruent, then it is the included angle and the triangles are the exact same. They are congruent. So if we trace this DE down and we trace this FE down and we notice, oh yes, that one is the one that's congruent, and that is called the included angle because it is between the 2 sides that are congruent. So we also have angle B that is congruent to angle E. Therefore, we can say that triangle ABC is congruent to triangle DEF by the SAS, or side angle side congruence theorem. So we did have to show that we had two sides as well as the included angle, and that's how you prove that two triangles are congruent by side angle side. So if you take a look at the on your own practice problems here, there are three different problems. You need to decide whether enough information is given to prove that the triangles are congruent using SAS. Now I just want to warn you that you want to make sure that the angle is between. So when you look at the way that these are written and then also the markings on the diagram, make sure that you can see that they are, that there's an angle in between the two sides. I'm just going to give you a little bit of a hint here. There is one of these is not going to work out. Okay, so one of them will not work out using SAS, and two of them will. All right, let's take a look at the next page. On the back here, we have to write a proof, and in this example, they want us to use the Hypotenuse Leg Theorem. Now remember, when we have a right triangle, the side that is opposite from the right angle is called the hypotenuse. All right, and then the two sides that join the right angle down in the corner there, those are called legs. Okay, so this one over here is also called a leg. This one right here is also called a leg. So when we go and look at our proof that we have to write, they're asking us to believe this information. Okay, so this is what we've been given, and we have to prove that this triangle ABC is congruent to triangle DCB. So this picture up here is the exact same picture as I have over here. However, the two triangles are not touching each other, and they're just kind of broken apart. So if I mark the things that we see in the information that's been given, side AB is congruent to side DC, and then they're telling us that BA is perpendicular to AC. So that means perpendicular just means that there's a right angle. And then also CD is perpendicular to DB. Now, the reason that we can say that BC is congruent to BC, of course, and you can see this here, is that they are the exact same side. BC in triangle ABC is the exact same side as BC in the triangle called DCB. All right, we're going to get to that in just a moment. So if you remember about proof writing, the first thing is generally given. Okay, so we have this information right up here. We're talking about the two sides that join and make perpendicular, an intersection that's perpendicular. Angle A and angle D are right angles. Well, we know that the definition of perpendicular lines form right angles. So definition of perpendicular lines gives us the information that those two angles become right angles when the two sides are perpendicular. Triangle ABC and triangle DCB are right triangles, so we can just say, well, that's the reason, because definition of right triangles, we know what that means. There has to be at least one right angle. Actually, there can't be more than one right angle. And then we come down to this one here where it says CB is congruent to BC. That's the one where I marked this side right here is congruent to itself. Anything that's congruent to itself is going to be reflexive. Okay, remember that reflexive property says that something is congruent to itself. An angle, a side, a triangle, etc. So then in part 5 here, or step 5, it says that AB is congruent to DC. That was given up at the top at the start of our proof. And then finally, did we have enough information to say that triangle ABC is congruent to triangle DCB? Well, if you take a look right here, here's an H. That information tells us that the hypotenuse is, congruent in each triangle. And then we have an L. The L says that the leg is congruent in each triangle. So, given that the hypotenuse and a leg are congruent, we can say, yep, these two triangles are congruent based on the hypotenuse leg congruence theorem. So, let's go ahead and have you do the next two, which are the on your own practice problems. Go ahead and give it a try. Of course, you should be using a pencil, so just make sure you're looking to find out which things are given. So here's the stuff that's given in this one. Take a look at the diagram as well. Make sure that you can see, what you need to see there. And then notice that I've given you a little hint here, the H and the L. So the last thing for the last reason should be the hypotenuse leg congruence, correct? All right, and then you have one last proof down near the bottom. Same thing. Go ahead and give it a try. Let me know if you have any questions, and we'll do lots of practice in class.